In this video, you guys will learn about work. Now, what you will be learning is work done by a constant force. Okay. Now, imagine you have a block. So, you have a block on a frictionless surface. Now, you are giving it a force. Let's say the force is making an angle of theta with the horizontal. Okay. Now, once you give a force, what happens? The body moves, correct? So, let's say the body is moving a certain displacement of d. Okay. Now, since F is the force and theta is the angle, now as you guys can remember, F causes a projection onto d, correct? Which is the horizontal. So, the projection will be nothing but F cos theta. So, what you have is F cos theta and d are in the same direction. Now, this is nothing but the scalar product definition, correct? So, what we have is we have work done. We define work done as a scalar product. Okay. Now, the definition of work done. So, the work done by the force is defined to be the product of component of the force in the direction of the displacement and the magnitude of this displacement. Okay. Now, the definition clearly says, now the component of the force is what? F cos theta. F cos theta into the magnitude of the displacement, which is d, right? So, we have F cos theta into d. This is the work done. Now, F cos theta into d is nothing but F dot d, because force is a vector, displacement is a vector, correct? So, we have W is equal to F dot d. Okay. So, this becomes the definition and the formula for the work done. Now, since we know what is work, now we'll try different ways of getting maximum work done and minimum work done. Okay. Now, see, since the force and the displacement, they are at some angle theta, the work done will be dependent on theta also, apart from force and the displacement, obviously. Like for example, let's say you're trying to push a wall. Is there any displacement? No, right? So once d is 0, obviously work done will be 0. Okay. Apart from that, now suppose let's say you have okay, many people are pushing a bus. Okay. Now many people are pushing a bus, meaning all the force are in the same direction and the displacement is also in the same direction, correct? Now, what is the angle between F and D here? It is 0 degree. So, cos 0 is what? 1. So, you get W is equal to just F into D. Okay. So, this is the maximum work done. Meaning, if the angle is 0 degree, the work done will be maximum. Okay. Now, work done could also be 0. I'm not talking about pushing a wall example. See, here, what if the angle is 90 degrees? For example, let's say a weightlifter weightlifts, okay, and then he's holding the bar up and he just walks. He's just walking. Here the work done is 0, because see, the force whatever he's giving to lift the weight is upwards, correct? And he's walking horizontally. What is the angle between them? It's 90. So the work done here is 0. Okay, so this is one of the examples. And we also get negative work done. See, negative work done is nothing but, see, in the derivation what we took that it's a frictionless surface, right? What if we have friction? Then the displacement and the friction, these two will be in opposite direction. So here the work done will be negative, because the angle becomes 180 degrees. Cos 180 is what? Negative 1. So work done will become minus F into D. Okay. So we have positive work done, 0 work done, and negative work done. Okay. So these are certain just examples what I'm giving. So think of your own examples where work done will be positive, negative, as well as 0. Alright. Since work done is a scalar quantity, we also have to look at the dimension formula and the SI unit. Right. So the SI unit is joules. Okay. And the dimension formula is m L2 T minus 2. Okay. So think of different examples and then think of different ways of solving a problem in work done.